Nearly 200 years after the first studies on the Timavo, the HYDROKARST project is ready to go into effect. The main goal of the project is to coordinate the management and safeguarding of the Reka Timavo aquifer by means of the quantitative and qualitative monitoring of the underground streams and surface areas of the classic karst. The project's aim is to guarantee the sustainable management of water resources by reinforcing the cross-border cohesion of this area.
Questo progetto ha offerto l'opportunità a quanti da anni studiano.
This project has enabled those who have been studying the karst waters for many years to pool and compare their data and ideas in order to produce a single hydrogeological model.
In modo da arrivare a un modello idrogeologico unico e condiviso. Nel contempo anche i gestori degli acquedotti.
And while those who manage the aqueducts know that the karst groundwaters will meet all our needs for the foreseeable future, they also realize that these waters are very vulnerable.
Dal punto di vista delle nostre necessità, però come tutte le acque profonde sono anche acque vulnerabili e quindi, diciamo, per tutelare se stessi e le fonti di approvvigionamento si sono uniti a questo team, a questa squadra di...
They thus decided to collaborate with the research team, sharing their data and knowledge of the distribution network in order to protect these sources from contamination and pollution in the future.
Che consentissero a tutti noi di proteggere le fonti di approvvigionamento ed evitare le contaminazioni o gli inquinamenti delle acque.
V okviru projekta HYDROKARST želimo.
The goal of the HYDROKARST project is to complete the research necessary for creating a conceptual model of the underground water. We want to know how these waters flow in the aquifers, where the underground passages are, where the water comes from, its affluence, and the amount of water that flows from Slovenia into Italy. The water that flows from our taps at home was held in the porous gravel and sand of the plain, or in the larger crevices of the karst limestone. There are, in fact, two kinds of aquifers, or geological bodies that contain water, porous and fractured. In porous aquifers, the water moves very slowly. In fractured aquifers, the water circulates through the gaps and openings in the rock formations. The geological characteristics are defined by means of field samples, perforations, geophysical explorations, and lithostratigraphic correlations. The hydrodynamic characteristics are instead determined by the constant monitoring of physical and geochemical parameters, test samples for microbiological and bacteriological analysis, and traces and tests in wells. The HYDROKARST project will create a 3D geological reconstruction of the hydrostructure of the classic Triestine and Slovene karst, and monitor its quality through the joint sampling of the waters from the sources and in the cavities that intercept the deep karst aquifer. This drill hole is 250 meters deep. It's located at Storie, near Cesana. The first drill hole was 20 meters deep, with a diameter of 250 millimeters. From that point to the bottom of the drill hole, the diameter is 203 millimeters. In drilling, we take great care not to pollute the karst environment. For this reason, we use a pneumatic drill without other accessories and powered only by compressed air.
V okviru sledilnega poskusa projektu HYDROKARST smo izvedli...
As part of the HYDROKARST project, we injected trace elements into the drill hole at Storie and took samples from the springs and wells in the grottos.
...mestih, tako izvirih, vrtinah in tudi v podzemnih jamah. Sledilo smo v vrtino inicirali...
We injected the trace liquid on April 10, and when the level of the Timavo fell, the uranin kept flowing for a long time. The monitoring lasted for nearly a year. We verified that 70% of the trace element was emitted through the mouths of the Timavo.
70% sledila pojavilo v izviru Timava.
This project enabled us to calculate the rate and direction of the flow, as well as the chemical and organic composition of the water. The classic karst is the site of what is commonly known as the underground network of the Timavo. This is a system of subterranean waterways, some of which reach far below sea level. The water flows both in large galleries and in the tiny fractures that characterize the rock formations. This underground drainage system and the surface karst forms were created by the water itself through chemical and physical processes that have been continuing for at least 8 million years. We need only consider the fact that today, more than 5,000 grottos have been explored in the classic karst. The Reka River, or Upper Timavo, originates on the slopes of Mount Letvo, on the Slovene-Croatian border. After flowing above ground for about 40 kilometers, near the village of Skocjan, the river disappears into the complex of underground galleries of the Skocjanske Jamy, which since 1986 form part of UNESCO's World Natural Heritage. The Timavo Reka enters the cavity, which is 6 kilometers long and 317 meters above sea level, and passes through several very deep caved-in doline. After flowing for 3 kilometers through another gigantic gallery with 26 waterfalls, the river disappears into the siphon of Dead Lake at 212 meters above sea level. The water temperature varies seasonally from 0.1 degrees centigrade to 30 degrees centigrade. The project's monitored water points are located in this hydrogeological section of the classic karst. The monitoring makes it possible to register the variations in water level, temperature and conductibility.
Il Dipartimento di Matematica e Geoscienze
The Department of Mathematics and Earth Sciences constantly monitored the karst waters, both in the underground galleries and in the fractured strata where the water circulates more slowly. Instruments like this one were used to monitor the level, conductibility, hardness and temperatures of the water. In particular, we monitored the major grottos on the karst. These curves show the variations caused by precipitation. Whenever there is precipitation, the volume and rate of flow increase, which reduces the level of dissolved salts. If we study the specific data, especially from the Trebiciano Abyss and the springs of the Timavo, we can calculate the time required for the water to flow from one point to another. Using the data from specific maximum flows, we can produce a table that can calculate flow times based on the volume of flow. All these data confirm that the aquifer is very vulnerable.
Ad un acquifero estremamente vulnerabile.
The Trebiciano Abyss is the most famous grotto on the Triestine karst. It was discovered by Antonio Federico Lindner during the search for sources of drinking water for the city of Trieste, and became accessible after months of difficult excavations. For decades, it was the deepest explored grotto in the world, and had a key role in the hydrological study of the karst, becoming an important underground scientific laboratory. The opening of the grotto is near the border between Trebiciano and Ferneti. It extends for 920 meters and reaches a depth of 354 meters. The waters of the Timavo flow at the bottom of the grotto in a large cavern. The water level can rise very quickly, reaching its maximum in 1 to 2 days from the start of precipitation, with an average oscillation of 10 to 50 meters. The water generally flows very slowly, less than 1 meter per hour, but can attain a maximum velocity of 830 meters per hour. The maximum level of 155 meters above sea level was registered in December 1915 after 13 consecutive days of rain. The system of sources of the classic karst is located in a narrow strip of land that extends along the coast of the Gulf of Trieste, from Auresina Mare to Duino, and then widens inland from Monfalcone in a series of heights and valleys. This area includes the actual source of the Timavo at San Giovanni di Duino, Lokovats and Moscanice, and the lakes of Doberdo, Pietrorossa and Sablici. The Auresina sources consist of 9 springs at sea level and extend for 350 meters. In 1859, they were accessed in order to provide water for the railroad and supply the Trieste aqueduct. Between 1900 and 1910, the springs were channeled to increase their conductibility. A dike was built to avoid contamination by seawater, and a drainage gallery was constructed. However, none of these works have been in use for many years. The springs of the Timavo, also called resurgences, or erroneously mouths, are the classic karst's main system of springs and consist of 4 ground springs in 3 branches. Subaqueous speleological explorations have discovered the passages which connect the underground springs and which form part of a large complex of flooded galleries that can reach 83 meters below sea level. In the area of San Giovanni al Timavo, the groundwaters originate in a catchment of about 1,000 square kilometers, 2/3 of which is composed of limestone and 1/3 of flysch.
Qui siamo sul Sorgenti Sardos.
We are at the Sardos spring, which contains karst waters that have percolated from the surrounding catchment area. This water is distributed continuously as drinking water in the province of Trieste and constitutes about 20% of total distribution. The waters of the Timavo are also karst waters, but are only used as a reserve when the water table is at a critically low level in order to preserve the table itself. The wells which supply the Slovene karst aqueduct are located in an area near the border between Jamiano and Brestovica. The water originates in both the Isentine karst, fed by the Isonzo River, and the karst aquifer. We're in the Klarici aqueduct, where there's a pumping station that supplies the aqueduct of the Slovene karst. There are 3 pumps with a capacity of 350 liters per second each. The pumps are positioned at a depth of 40 meters, in wells which have a total depth of 70 meters.
Nahajamo se v objektu Vodarna sela. Objekt je...
We are in the Sela Aqueduct compound. This is where the waters extracted from the Klarici wells are treated. Here the water is treated by means of pressure filters before being distributed to consumers.
Za čiščenje vode kot preventiva, preden gre voda v omrežje potrošnikom. Po čiščenju vode iz filtrov...
After being filtered, chloride gas is added to the water, which neutralizes any possible pathogenic agent in the drinking water.
Infekcijsko sredstvo za preventivo v omrežju. Voda preko filtrov se zbira v...
After being filtered, the water is collected in basins with a capacity of 1,000 cubic meters each. It is then pumped into the Slovene Karst aqueduct, which supplies the upland, and into the Cezana aqueduct, which supplies part of the coastal area.
S katerim se oskrbuje kraško planoto, del Brkinov in del obale Križanskega vodovoda.
The groundwater is inhabited by a rich and diversified fauna, from microorganisms, which can only be seen with a microscope, to tiny worms and crustaceans, to the larvae of various insects that live in the surface waters, and even an amphibious vertebrate called Proteus. The microorganisms, as well as some of the larger organisms, help to maintain the high quality of the water and indicate the direction of its flow within the karst hydrostructure. During the HYDROKARST project, we carried out explorations in search of the subterranean fauna of the karst. Based on previous studies and our own samples, we have identified more than 100 species so far. Proteus is the best known of these species, but there are also many tiny crustaceans, which is an indicator of the high quality of the water. More than a century of research has shown that the physical-chemical characteristics of the waters between the Isonzo River and the Reka Timavo are quite similar, with two main directional flows, one north to south-southeast and the other southeast to northwest. However, certain parameters such as temperature, conductibility, hardness, and the presence of chlorides make it possible to distinguish three different groups: the sources of the Timavo, the sources of the Sardos and South Moschenice, and the sources of the Pietro Rossa, Sablice, and North Moschenice. In addition to the main chemical components, other parameters enable us to distinguish the three types of water which converge in the area of San Giovanni di Duino. During periods of overflow, the water of the Timavo differs from other karst streams due to the presence of clay carried from the upper Timavo and introduced into the groundwater circulation at Scozien. This is excellent water, which is constantly monitored through daily analysis, both in continuum, or at source, and in the laboratory. Chemical, physical, and microbiological tests are performed on samples taken from the entire water network, from the sources to the distribution points. The water is constantly monitored, verified, and controlled, with up to 5,000 individual analyses every year. This guarantees that the water is safe in terms of its chemical, physical, and microbiological composition. In the microbiology laboratory, we monitor the quality of the water. The main microbiological parameters we verify are those for total coliforms, E. coli, and Enterococci. The system we've adopted for analyzing the water is the Quantitri Sealer. This method has been validated by the Upper Institute of Health and gives results within 24 hours. In addition to the standard filter membranes and pore plate methods, we use these envelopes sealed by this machine, which indicates the growth of total coliforms, E. coli, and Enterococci. For the total coliforms in E. coli, the results look like this. The sample without microbe growth appears white, while the sample with total coliforms appears yellow. We can thus quantify the number of microbes based on the count of positive wells. If we pass them under the UV lamp, we can count the fluorescent wells, which gives us the count for the E. coli. The same method is used for the Enterococci. The negative plate, where there is no microbe growth, appears blue, while the positive plate appears green. Achagas apps AMGA is currently creating hydric districts for the areas of Padua and Trieste. The main goal is to reduce loss in the water distribution network, which currently amounts to 38% of total.
Noi contiamo sul territorio di Trieste di contenere...
In the Trieste area, there's a total loss of 30 to 32 million cubic meters of water every year. We are trying to reduce this loss by 2 million cubic meters annually, which is a significant amount.
Rappresentano una cifra significativa.
We are often unaware that many everyday activities, such as driving a car, doing the laundry, or fertilizing the garden, and everything which, intentionally or not, ends up on the ground, sooner or later enters into the subsoil, to reappear months or even years later in the tap water in our homes. Water from rain and rivers which enters the ground carries with it all the substances with which it has come into contact. Most of these substances are not harmful, but some, in high concentrations, pollute the aquifers and can endanger our health. It is thus important to avoid contaminating the soil and surface waters. We should keep in mind that the karst cavities aid the deep emission of all pollutants, and that this emission can be very rapid, even when the water flows at great depths. The use of trace elements has shown that when the waters of the upper Reka Timavo are high or overflow, they can reach the Duino Springs in just 2 or 3 days.
Quello che Philip ci sta mostrando in queste immagini sono tutta una serie di mappe tematiche.
Philippe is showing us a series of thematic maps that show the lithology, geomorphology, and hydrogeology of this area, as well as the precipitation levels. When all these maps are overlaid, they show this area's vulnerabilities and the fragility of the karst aquifer.
I risultati finali del progetto HYDROKARST ed è un risultato estremamente importante perché rappresenta la...
The unified map is one of the key outcomes of the HYDROKARST project, because these danger points make it possible to map the level of risk for any pollution event within this area.
E possiamo essere in grado di ottenere una sorta di rischio a quelle che sono gli inquinanti che possono sversarsi all'interno del territorio. Queste mappe, in funzione di quelli che sono i punti di emungimento...
The data for these maps are provided by the monitoring points, such as the ones at Brestovica and Sardos, making it possible to define joint areas of protection for both Italy and Slovenia.
Una serie di aree di protezione che in questo caso sono aree di protezione che vengono costruite in maniera condivisa.
We hope that these areas will be used to protect our aquifer in the future.
Andranno ad essere, speriamo nel futuro, applicate per far sì che il nostro acquifero venga protetto.
Both Italy and Slovenia extract water from the same karst aquifer, which thus knows no borders. The water flows freely from Slovenia to Italy, and only shared rules and regulations can protect these waters for the common good.